question says, what is the wavelength in nanometers of radiation that has a frequency of 4.61 times 10 to the 14 hertz, or seconds to the minus 1, and it tells us that 1 meter equals 10 to the 9 nanometers. So when we talk about electromagnetic radiation, if we know one of the three things, frequency, wavelength, or energy, we can calculate the other two, because frequency, energy, and wavelength are all related by constants. So in this case, we want to find the wavelength given the frequency. So we need to use c, the speed of light, equals lambda, the wavelength, times nu, the frequency. So c, which is 3 times 10 to the 8 meters per second, equals lambda, the wavelength, which has to be in meters, times nu, the frequency, which has to be in hertz, or seconds to the minus 1. So in this case, we're actually trying to solve for lambdas. We want to divide both sides by nu, and we get lambda equals c divided by nu. So again, c is a constant, the speed of light in a vacuum, 3 times 10 to the 8th meters per second, divided by the frequency, which is given, 4.61 times 10 to the 14 seconds to the minus 1, which is the same as a hertz. When we do that, we get 6.51 times 10 to the minus 7 meters. Note that the question says, what is the wavelength in nanometers? So we have to take this meters and convert it to nanometers. So if we have 6.51 times 10 to the minus 7 meters times, we have the equality here. 1 meter is 1 times 10 to the 9 nanometers, 1 billion nanometers. So we want meters to cancel out, so we put the 1 meter on the bottom, and we put the 1 times 10 to the 9 nanometers on top. Note that these are a definition, they're not a measurement, so there's no sig figs in this. And when we do that, we get 651 nanometers. There should be a 1 there, nanometers, which is reddish light. So if we look here, 6.51 times 10 to the minus 7 is hundreds of nanometers. Hundreds of nanometers come up a lot in these types of questions because they're in the visible spectrum. So this is basically how we would solve this problem.